Perfect. All right.
Okay.
Did you guys want to go over the
Check this out.
Yes, please, if they're done.
part 2? Do you guys have any questions about that?
Just a second.
There are tons of them, but
There was so many. It was a way long one this time.
Was.
I mean, luckily, the part 2, all the questions,
They were what?
It's in your room.
but
Hey, let's look in your room. What?
so this time I just figured out that the extra video tutorials
Uh-huh.
that actually go through all the problems on the preparation thing, because there was
Really?
what number was it? It was number 3, the part B with the 40th percentile. I had no idea how to do it. I couldn't remember.
Yeah.
I finally figured out that he goes through all of them, so that helps.
Oh,
Huh.
I've never looked at that.
No.
No.
Need to make more time for those, I guess. They'll be helpful.
Yeah. Alrighty.
Very good to know.
Huh.
Okay. Anybody have any questions?
Not for part 2, or well, not for any of it. Not for
Yeah.
the thing.
Yeah. I think I'm okay.
Yeah. I was kind of proud of myself because I was like keeping up with it. I was like, okay, I know how to do this. I know how to do this.
That's the best feeling ever.
Yeah. Really. Yeah, it was
Especially
very,
since
very
we
long.
have now. Alrighty. So then, do we want to get started with the quiz?
Yeah, I'm good with that.
In the kitchen. Sounds good.
Can. You guys good?
Yes.
Number 3 says, use the normal probability applet to find the combined area under the standard normal curve that is to the right of z equals 1.358 and to the left of z equals negative 0.1358. And round to 1.358. Oops.
Okay.
So it was to the right of the positive and left of the negative. So just the outside parts, right?
Yeah.
Okay, I got 0.1745 or 0.175. Is that what you got?
Hold on just one second.
Mom's getting home. So we'll be back in a minute, Mom.
All right, you got what?
0.175.
Oh, I put in the wrong one. Here, hold on.
Mhm.
0.1745?
Yeah,
Okay, yeah.
0.175. So far, so good.
Awesome. I wish they would just all be like that one.
Yeah.
I actually get that. All right. All right, number 4.
Yeah.
Okay, the United States Coast Guard assumes the mean weight of passengers in commercial boats is 185 pounds. The previous value was lower, but raised after a tragic boating accident. The standard deviation of passenger weights is 26.7 pounds. The weights of a random sample of 48 commercial boat passengers were recorded. The sample mean was determined to be 177.6 pounds. Find the probability that a random sample of passengers will have a weight that is as extreme or more extreme, either above or below the mean, than was observed in this sample. Round your answer to 3 decimal places. If the answer is 0.8976, oh, that's easy. Let's see.
We're not only interested in values that are lower than this.
The probability that a random sample of passengers will have a weight that is as extreme or more extreme.
Okay. Previous value was lower but was raised after a tragic boating accident. Okay.
So do we use the
New mean.
sample mean after?
Sample mean?
Yeah, the 177.6.
That's what I'm trying to figure out.
I think so.
That's what
Because
I'm
it's sample mean,
thinking.
which would be the X bar, right?
Yeah.
But, find probability that a random sample of passengers will have a weight that is as extreme or more extreme. Okay. So that would, okay. As same as in the positive direction. So what's the
So are we plugging this into the applet thing?
Gosh, I hate this thing. I think so, yeah. Because we'll need to
On the z-score.
the area. The area is the probability. And that's what we'll use.
Oh, yeah. Okay.
Oh, below it and then times 2 because it'll be also up. Okay, let me try out the equation with it. Okay, so we have 177.6 minus 185 divided by the standard deviation is 26.7 divided by square root of the sample size, which is 48. Okay. So, hang on. 185 divided by 26. Okay. So the z-score I got is negative 1.92. Negative 1.92 represents the 177.6. And so it's saying, what the question's asking is, that is extreme or more extreme, either above or below the mean. So seeing as far as it is it just taking the two outside sides? The below negative 1.9 and above 1.9? Is that what that's asking?
That's what I was guessing.
That's what I'm thinking.
That's what it sounds like, but don't know.
Because it says as extreme or more extreme means that we are not only interested in values that are lower than the ones we observed, but also values that are as far away from the mean as ours in the positive direction.
So
it
it would
either
have to be both sides.
both sides, right? Because it's
Yeah.
just as far away, just on the positive side.
I
Okay.
think so.
Okay. So for the area for that, I got 0.0549 or 0.055 to 3 decimal places.
0.05. Alright. Let's see. I keep getting the wrong thing for the z-score. For the value, because you go value minus the mean. So is it 177.6? Is that the value?
Yeah.
So 177.6. And then, so the mean, what is...
The mean is going to be the 185 pounds.
Okay. Oh, the mean weight. Okay.
Because the mean weight, that's 185 pounds, is the population mean, and then the 177.6 pounds is the sample mean. So the population mean is the mu, the weird looking backwards y, and then the sample mean is the x with the line over top of it.
Okay.
Okay,
That
that makes sense.
makes more sense to me. So, divided by 26.7. Alright, so what did you enter for the z-score on that then?
Negative 1.92. Is that what you got?
For some reason I got a different answer. I got negative 0.2771.
What's your equation?
What was that?
What's your equation?
I did the 177.6
Mm-hmm.
minus the 185,
Mm-hmm.
and then I divided 26.7. Oh no.
Yeah, you want
divided 26.7.
26.7 divided by the square root of 48.
Oh, divided by the square root of 48. That's what I missed.
So negative 1.920.
Mm-hmm.
And then enter that into the.
Z-score. Yeah, the one on the left.
Okay.
Yeah.
Sorry, I'm almost done. I've almost got it.
That's alright. Our goal is 100. That's okay to do.
Yes.
Right.
Definitely.
So the standard deviation, you said you do the 26.7. Is it times the square root of 48
Divide.
divided by?
Mm-hmm.
Oh, it says right there. Okay. 26.7. All right, you got negative 1.9201.
Mm-hmm.
Okay, I'm on the same page now. Sorry.
No, you're good. You're good. That's, I guess, the point of these is to make sure that we're kind of all
Yeah,
understanding.
it's kind of nice.
All right, so for the area, we got 0.055.
Yes.
Okay, awesome. Okay, I'm good to go.
Okay.
Okay, which of the following will have a smaller standard deviation if 9 observations are randomly drawn from a population?
If it if it is one of those two, it would be the sample means, right?
That's
Because
what I
it's the average of all the samples instead of just the individual ones,
Uh-huh.
which would kind of bring them more close together, right?
I think so.
But whether or not that's like enough.
Whether or not it is that one, yeah.
Oh, it says if nine observations.
Oh,
Uh-huh.
randomly drawn from a population.
Be
A smaller standard deviation. 9 observations are randomly drawn.
would be. Do I have a smaller standard deviation? Do you think? I don't know if there's a way to tell, just because.
Yeah.
One, we don't know how much there is a population. 9 observations isn't greater than the 30
Uh-huh.
that we're about. And I don't know if that would make a big of a difference.
Yeah.
So
I don't
maybe,
think you can figure it out.
yeah. I don't think
Thinking.
9 observations are randomly drawn. And 9's not a large number anyways, because remember the
Yeah.
law of large numbers was the greater the number, the closer the, was it the two means or was it the
The
small?
mean? Yeah.
deviation?
I think it was the means.
Okay, I'll look up the standard deviation.
The population mean and then the sample mean, I think, would be closer to equal, I think is what it was. That doesn't
Oh, okay, here we go.
make sense.
Standard deviation. So it is the sigma, which is the original standard deviation, divided by the square root of the sample size. And so if there's 9 observations, we don't know what the original standard deviation is.
Yeah.
So that I don't think there's enough information.
So it's, yeah, it can't be determined.
Just like how I'm trying to figure it out in my head, I need those.
We're just missing something.
Yeah.
Yeah.
Okay.
I think so.
Yeah, that makes sense.
Yeah.
Better be right.
Right. Right. Number 6. Okay, which of the following results implies that the spread in X decreases as the sample size increases?
Is that the central limit theorem?
That's what I was just looking at.
Spread in X decreases as the sample size increases.
Okay. Samples large, central limit theorem implies the sample mean is one. I know that had to do with the normal distribution. So let's see. What?
Did you do that in Slack?
No. Or I don't know.
Let's see. Which of the following results implies that the spread in X decreases as the sample size increases?
So take some quiet on that.
Sorry.
That's good.
Okay.
Was this on our homework the other day? The other thing that we read?
The lesson?
The central limit theorem.
Was it on this one? Is that what you're
Was it
asking?
on this one or lesson 6?
Oh, both. I went back to lesson 6 to look at it.
For the definition? Okay.
But it is talking about the law of large numbers states that if the sample size is large, then the sample mean will typically be close to the population mean. This happens because the standard deviation will get smaller.
Okay.
And now
So,
I can't remember what the question was.
so
Implies
it's,
spread of X decreases as the sample size increases. Okay, so yeah, because it's saying the spread.
the spread in
The spread
value
decrease.
decrease as the sample size increases.
Gosh, they're so confusing.
I know.
No.
All these
Read
words.
it like 50 times to understand what they're asking.
Because they keep like interchanging them.
Yeah.
Yeah.
Okay, but it does say the law of large numbers states that as the sample size gets larger, the sample mean will get closer to the population mean, and the sample mean is the X bar.
So the law of large numbers then?
I think so. Yeah, because X is bar. X is the bar, and that it
Decreases.
yeah, the spread in
increases.
sample mean.
So they're just opposite, kind of.
Okay. Whew.
Okay.
So it's saying like if you have a greater sample than the law of large numbers, then it's going to be more normal distributed.
The central limit theorem? Is that what you're saying?
Yeah, that's what I was thinking too.
Just in if you pull up lesson 6, the summary part at the bottom, it has the law of large numbers in there, and it says that X bar will get closer to the population mean, and I don't know if that means if that's the same thing as what it means as the spread.
Yeah.
Choice in words is making it very confusing.
Yes.
Yeah.
Lovely. Sample size gets larger, the sample mean will get closer to the population mean.
I almost feel like it's the law of large numbers, because it sounds like the central limit theorem is where it increases. You're dealing with big numbers instead of it lowering. But I don't know.
Yeah, it's just if the standard deviation of a sample mean gets smaller, what happens to the values? Which means it doesn't say it necessarily decreases, it just says it gets closer
Yeah.
to.
Alright, well.
Law of large numbers states that the sample mean will be close to u. Which one is that? Okay. Right, I'm good with law of large numbers.
That's the one that seems to me like it fits the most.
Yeah, because
Well,
it is talking about the spread, and that's what's confused me. So, like, how it's distributed. If it's a central limit theorem, then I don't know if it's the spread decreases because it becomes more bell-shaped,
Yeah.
and it's not so spread out. But the numbers are the same, so the spread is going to be the same.
yeah.
But the sample size increases, there's more sample means, and I don't know if that plays an effect on it.
I don't know. I don't remember reading this anyway.
Doesn't even talk about the.
Yeah.
It doesn't even talk about the law of large numbers in lesson 7.
No,
Yeah.
it doesn't.
Bring it up. It talks about the central limit.
So maybe it's just a central limit theorem.
Yeah.
Maybe.
That totally could make sense if that's what it is, but
It's just it doesn't say anything about the spread.
Yeah. Let's see.
I mean, the closest thing I can get to it is it just says the central limit theorem guarantees the distribution of X bar is normal if the sample size is large enough.
Uh-huh.
Once we determine the sample is normally distributed, we can compute probability.
Yeah, nowhere in lesson 7 does it say the word spread.
Yeah, no.
Control find. Dang it.
Which, if we just substitute spread for distribute, like, distribution. But it doesn't, I don't know if that's what if he's asking, like, it decreases.
Yeah. So in lesson 6 it says, okay, when it's talking about the distribution of means graph, it says, we're interested in the shape, center, and spread of the distribution of means graph.
Mm-hmm.
But it doesn't really say what the spread is.
You said that was in lesson 6.
Mm-hmm.
So probably spread is the distribution then.
What I'm
Graph
thinking.
represents distribution, blah, 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 blah. Yeah, because, well, it is lesson 7 and it doesn't talk about law of large numbers. What do you guys think? But, like, as far as my understanding of it,
That's why I'm kind of thinking central limit, just because of that.
So
Yeah.
if it's saying that the sample size is increasing, then it could just be more like the central limit theorem. If it's over 30, then it's going to be normal.
yeah.
So,
Another reason I would think it's central limit is because it's talking about the spread, which, from my understanding, is the distribution of it, so how far apart it's spread. So the central limit theorem is saying as the sample size increases, it's not going to be right skewed or left skewed,
Yep.
because you have the outliers, but it's going to become, like, and I don't know if the right word for that is decreased as much as it's
yes.
compact.
Yeah. I don't know.
Like,
I'm
I don't
thinking
know.
central limit theorem.
Yeah.
Right now, anyways.
Yeah. So maybe we'll just put that.
Yeah, I don't know.
Okay. Go to the next one.
Yeah.
Yeah.
Okay. Scores on the quantitative portion of the GRE are approximately normally distributed with mean of 150.8 and standard deviation of 8.8. Use this information to answer questions 7 through 10. So Diane earned a score of 160 on the quantitative portion of the GRE. What is the z-score corresponding to Diane's score?
Okay. She did a 160. Oops. And if there's not a sample size, we just divide it by the standard deviation, correct?
Yeah,
I think so.
I think so. So I'm guessing it's 1.045.
Yeah, that's what I got. How many? 3 decimal places?
You got what, Mel?
1.045.
Did you do 160 minus 150.8?
Uh-huh.
Yeah.
And then divide by the standard deviation, so 8.8.
I must be pushing the wrong buttons or something, because I thought I did that exact formula. Okay, 1.045.
I hate that.
Yeah.
Well, that's what I was doing on number 4. So I was going to ask you guys before we finished, what was the answer to number 4?
Number 4?
Yeah, was it 0.055?
Yeah.
Or no,
Yeah.
number 3. Sorry, number 3. 0.475?
0.175.
Yeah.
Oh, okay. Just kidding. Thank you.
That could have been bad.
Yes.
Alright, so... Oh, we're just finding the z-score on this one?
Yeah,
Yeah.
for 7.
Oh. So 1.045?
Yeah.
Mhm.
Alright. Okay, I'm ready to go on.
Okay, 8 says, what is the probability that a randomly selected student will score above 160 on the quantitative portion of the GRE? That would just be to the right of the positive 1.045, correct?
Yeah.
Yeah.
Okay. You guys get 0.148?
Yes.
Mhm.
Oops. Ooh, wrong one. There we go.
Awesome.
Alright, so number 9, a random sample of 5 students was selected to take the GRE. Their scores are 160, 175, 163, 149, and 153. What is the z-score corresponding to the sample mean of these students' scores? Okay, so we add them up and divide by 5, right? To find the
Yeah.
sample mean.
Mean. Mhm.
I got 160. So you got?
Yeah.
Ah, I hate that. Okay, so then subtract. And since, okay, so.
And then do we divide by the 8.8?
Yeah, you'll do the 8.8 divided by, because it has a sample size. The sample size is 5.
5. Mhm.
Oh, okay.
So 2.338.
Yeah, that's what I got.
Okay. You did 160 and you divide that by what?
160
160,
minus what we are.
150.8.
Yes.
160 minus 150 point. Oh, okay.
Which is the mean, and then divide by the standard deviation divided by square root of 5. Right?
Yeah, that's what I did, because the sample size is 5, n equals 5.
And so you got what?
2.338.
Gosh, I am not getting this for some reason. Let's see. So we had 160
Mm-hmm.
minus 150.8,
Mm-hmm.
and then you divide that by, is it 8.8 divided by 5? Or this?
Divided by square root.
Square root of 5.
Oh, that's just all divided by the square root of 5?
No, you're 160 minus 150.8. Take all of that divided by 8.8 divided by the square root of 5.
Okay.
So you'll do 8.8.
Hmm?
You're going to take the 160 minus 150.8 and divide it by that answer.
Okay. And you guys got what?
2.3.
2.338.
Okay, I got it.
Yeah.
Good. Good work.
Gosh.
Hey, it happens to all of us, all right.
All right, number 10. What is the probability that 5 randomly selected students will have a mean score that is greater than the mean achieved by the students in the previous problem? Round to 4 decimal places.
Because that's the sample mean. So we put that into the thing, right?
That's what I'm thinking.
Yeah. So put the z-score into that and take what's above it.
Just above, yeah.
Is that what it said above?
That
So.
they'll have a mean score that is greater than the mean, yeah.
Okay.
Of course, it would be an awkward number. Oh, it says to 4 decimal places.
Oh,
Oh.
did you get .0097?
Yeah, so. Everyone good for that one?
Yeah.
Okay. Suppose the mean GPA of BYU Idaho students is 3.5 and the standard deviation is 0.7. It is well known that this distribution is left skewed. A random sample of n equals 81 students will be drawn. Use this information to answer problems 11 through 15. What is the shape of the sampling distribution of the random variable x bar, which represents the sample mean of the 81 students who are selected? And since it's n is greater than 30, it'll be approximately normal, right? Because of the central limit.
Yeah. Yeah.
Mm-hmm.
Okay.
Yeah, awesome.
What is the mean of the distribution of the sample means for all possible samples of size 81 that could be drawn from the parent population?
One decimal place. Okay. What is the mean of the distribution? Oh, because it's a normal distribution, or actually, because the sample size is greater than 81, we treat it like normal distribution, right?
Mm-hmm.
So it would be the same mean as it would be the 3.5, correct?
Yeah.
Does that sound right to you guys?
I think so. Yeah.
Yeah. I don't know what else you would pick.
Yeah.
It doesn't give you like another sample
What's the mean?
value or something.
Yeah, I think it's.
Because of the sample size is so large, we just treat it like it's normally distributed.
Okay. Yeah, that makes sense.
A large sample, it would be, I guess. Right?
Okay.
Yeah, good.
Okay. Alright. 13. What is the standard deviation of the sampling distribution of the random variable x, the mean of the 81 students who are selected? Okay, what is the standard deviation of the sampling distribution?
Sorry, what number did we get for 12?
3.5.
Oh, I don't know why I didn't put it. I was agreeing to it. Okay. All right, sorry. 13.
And standard deviation equals the original standard deviation divided by the square root of the sample, right?
Oh, okay. Yeah.
Yes.
So,
The original.
81.
2, 3 decimal places. Okay.
Oops. Oh my goodness. Okay. Did you guys get 0.078?
Yeah.
Took me a second because zeros always confuse me. I'm always like,
Yes.
what's 3?
To be count 1, 2.
Okay. Thanks.
All right, number 14. What is the probability that the mean GPA for 81 randomly selected BYU Idaho students will be less than 3.3? Round to 3 decimal places.
Okay. So we do the 3.3 minus the 3.5 divided by
0.7.
what's the standard deviation? 0.7
Mhm.
divided by the square root of 81.
I'll put that in the applet.
It says less than.
Square root of, we do the square root of
81.
oh, okay.
because that's sample size.
Okay. Right.
Negative 2. Okay. And it says less than 3.3, correct?
What was that?
Yes.
Oh, yeah.
Oh, less than 3.3. All right.
Uh-huh.
Did you get 0.0051 or 0.005? I guess.
Let's see.
Lost my applet. Okay.
Well, I did the problem wrong again, so just a second. I don't know why these ones just get me, but they do. So we did the 3.3 minus the 3.5, or
Yes.
yeah, minus 3.5. Then we divide that by, let's see. So we divide that by the 0.7 divided by the square root of 81, right?
Mm-hmm.
Okay.
Did you say you got 0.4872?
For the equation or for the probability?
For the probability.
No.
I got 0.0051.
2.
You did?
Yeah.
What'd you get for your z-score, Mel?
I thought I got 0.0317.
I got negative 2.57.
Yeah.
Okay, let me try it again. Let's see. Still got the same. Okay.
You did the 3.3 minus 3.5
Uh-huh.
divided by 0.7 divided by the square root of 81.
Mm-hmm. Divided by square root 81. Okay. Must have missed a number. 2.571, you
Yes.
said? Okay. Okay, so 0.9949.
We're going to do less than 3.3. So the left side.
So you would shade in the middle and then the other left side, right?
No, because it was negative 2.57. So this score on the left is what the mean is when the mean is the 3.3.
Okay, so 0.0051.
Uh-huh.
Yeah.
Okay. Which would be 0.005.
Mm-hmm.
Oh, right. Okay.
Okay. So what is probability greater?
Yeah. Isn't that just the same? Oh, wait a second.
So I swear on one of these we took this, or we did this one and it was wrong, but I can't remember which one it was.
It would have been if it was between 3.3 and 3.7 or something, whatever the side is, because we didn't do the 1 minus the each side.
Uh-huh.
Okay.
But I was just looking at this one, and it says what's probability the mean GPA will be greater than 3.3, so that's going to be the middle and the right side.
Yes.
Okay.
And
So-
also minus 0.005. 0.05, which equals the 0.995.
Okay, perfect.
At least in like on the preparation worksheet, I had that one minus the two outsides just to find the middle, but it's the same as just shading the middle and leaving them.
Okay.
Oh, okay. Yeah.
Right.
Okay.
Because all of that is the probability of getting higher than a 3.3.
Uh-huh.
Okay, so it's 0.995.
Yeah.
995. Okay, and just real quick, number 5, I kept thinking about this one, was which of the following will have a smaller standard deviation if 9 observations are randomly drawn from a population? And I'm like, still, I don't know.
I know. Ugh.
Because if I think about it just like real lightly, in my head, it's like, okay, well, obviously, it's just asking which is going to have a smaller standard deviation.
Uh-huh.
The sample means is going to have a smaller distribution than that of individual observations. But I don't know how many, okay, you have 9 observations, and then you have each, I don't know if like the combination of 4 or however many it would need would make a difference, because say you have all of the numbers. I'm just trying to like think of an example in my head.
I know, I can think of any.
Because that one on the website we used, was that on Tuesday? Or was that yesterday? Wow, was it really just yesterday we used that? Goodness.
Crazy.
Okay. Just think about that.
You make me yawn.
Me too.
Sorry. So, like the sample data, it's all spread out, but then you have the distribution of the means, which is the sample mean, and you just have one. Okay, so that was like 5, and then you do it again. But and obviously the sample means are going to be closer together, not so spread out like these ones.
Yeah.
Yeah, so but I don't know how many you need. See,
Yeah.
and the standard deviation for the distribution of means says it's 7.3. When the standard deviation of the original thing's like 5. So do you think, should we just stick with the cannot be determined?
I guess, gosh, I just...
Now I think about it for a second, I'm like, oh, it's got to be this or what.
Yeah, right. And then you stop thinking or you
And then
overthink.
you notice a different word, and you change your whole thing.
Yeah.
Because it's the sample means, so that's the averages of any of the certain amount. But we don't know how big the samples are. It just says observations are randomly drawn from a population.
Uh-huh.
And I don't know if those... The distribution of individual observations is obviously going to be more spread out than sample means, right?
Yeah.
But I don't know if that's what it's asking or if it's like being more specific. And I don't know if like a smaller amount of samples will make a difference.
Ugh. Man.
Right? Oh, like 5 and 6, I just wish that they could be.
Yeah, those two. Gosh.
Always got to be a couple.
Mhm. Because 9's not even a big number anyways.
Yeah.
So I don't know if the sample means will be. Sorry, but
No, it's
No, good.
darn.
it's so annoying.
So I'm Googling it.
That'll help.
Like, I can't find it anywhere.
Right? Because the distribution's smaller. I don't know if the. I mean, it would make sense that the sample, like, if it was one of those two choices, it'd obviously be sample means, but I
Yeah.
don't know if there's.
That would make sense to me, but I don't know. I don't know.
Don't know. Not finding anything.
Not all random. Dimensions or anything.
I don't know, you guys.
I don't know. I'm just thinking, like, it can't be that complicated. It's probably, like, super simple.
I know, I'm sure we're just overthinking.
Oh, that's so annoying.
Yeah.
Yeah, but
Duck.
Just weird that, I don't know, just doesn't make sense in the reading.
How about we just tell Mom that we want shopping? Okay? Okay, what's your name?
What else do you want to say? Is
There's so much.
is individual.
Huh?
Oh, don't put it in the fridge.
Oops. 1 second. Let me just check.
Okay, so if it's a large population, then the mean will be close to the sample mean.
Uh-huh.
But since it's not large, I don't think it's the second one.
Glad.
And the distribution of the individual observations. We'd have to know, like, what they were, right?
Sometimes I think that, and then sometimes I don't.
I know.
Hey. We're gonna go get some.
I don't know. What do you guys think?
I don't know. I'm just thinking it's can't be determined, but I just don't know.
Stick with that. I don't know either. And I'm sure we'll see the answer after and we'll be like, ah, of course.
Yeah. Because it says which of the following will have a smaller standard deviation. If you have nine of them are just the random ones
Yeah.
over everywhere, and then you take the distribution of the sample means, which is just all of the possible averages,
Uh-huh.
would be closer together as far as standard deviation. But I don't know what size this. What are the? You can't find a sample mean. I don't know how to find it.
Yeah.
I mean, you take all of them divided by 9. Is that what you do?
No idea.
Maybe?
We'd have to find the mean divided by. Then we'd have to figure out the standard deviation. I don't know. Ugh. Brain doesn't think that hard.
No, mine doesn't either.
Hmm.
All right. Well, we're not getting anywhere with it.
Yeah, I'm not finding
Oh
anything.
my gosh, I just
Right.
don't know.
Crazy. All right, I'm just gonna submit.
This cannot be determined.
Yeah. Ugh, yeah. I think I'll keep battling it. If I don't. Alright. Are we good?
What?
Dang it! I wish I could tell you guys what the answer were.
I just admitted it.
Gosh.
Seriously?
Man.
Mine is taking forever to submit.
That's what mine was yesterday, and you guys are all like, "Oh man,
Oh,
answer."
Dang
No.
I told you I wish 5 and 6 were deleted.
Yeah.
Yeah. Oh.
The
I'm
two-
still counting
two
it as
we have
100.
problem with.
That's so not fair. We were saying it was the law of large numbers too.
Uh-huh.
Yeah.
But then we said it wasn't in the lesson, so
Yeah.
Right?
Dang it.
apparently it doesn't have to be in the lesson.
Yeah.
In the previous.
Doesn't matter.
That's lame.
Oh well.
Well,
Better than yesterday.
Yeah.
yeah. Good work, you guys. My brain is shot, I think, right now.
Agreed.
Oh, gosh.